Let's talk about what actually happens with a TBI. The most important thing that your brain does, and this is how I explain all this stuff to my patients, the most important thing that your brain does is help you make sense out of where you are in the world. Now, there are a host of different types of classification systems of brain function, different types of brain organization scales, and so on and so forth. And this is not an official one. This is something that I just basically made up for my patients so that I can explain this stuff to them. But this is how I make this relevant to them. I'm like, you gotta think of things in terms of primary and secondary and tertiary brain function. Now, tertiary function is basically cognition, executive function, attention, focus. That's the level that you live at. That's consciousness. I always tell, if my patient Sally, I'm like, this is where all the Sally pathways are, all right? And then you get into the secondary stuff, and the secondary pathways are about like memory and emotional regulation. But what's primary? Primary is all about where's the world, where are you in relation to the world, so that you can survive and adapt to the world. And those pathways are visual systems, vestibular systems, and proprioceptive systems. So eyes, inner ear, and then feedback from muscles and joints, all right? The most important thing that your brain does is help you figure out where the world is. If you don't know where the world is, you can't adapt to the world. If you can't figure out where you are in relation to the world, you likewise can't adapt appropriately. And when we're talking about adaptation, we're talking about survivability strategies, all right? So the most important stuff is all of those primary pathways. Now, the brain uses a bunch of different sensory systems to figure out where you are in the world. There's proprioception. Proprioception is basically stretch receptors from muscles and joints, right? That's all this stuff. Now, there's this process called sensory reweighting, and reweighting basically means how much weight is your brain going to ascribe to a particular sensory pathway at any point in time so that you can figure out where your body is, how it's moving, and how you can stabilize, all right? And most people look at this from the perspective of proprioception being predominant. There's literature that implies that proprioception is about 70% of what you use to make sense of where you are in space, and that's all the physical stuff. That's all the feedback from muscles, joints, that's joint injuries affecting proprioceptive feedback, and that's the standard sort of structural medicine stuff that most people engage in, and that's all great, but your brain can shift emphasis way more in different directions towards visual systems, towards vestibular systems as you move through a complicated environment. There will be times where other pathways are far more important than proprioception. The other ones are vestibular. Now, your vestibular system are basically receptors in your inner ear that tell you where gravity is, they tell you where up and down are, they tell you about translational movement, forward, back, side, up, down, and roll, and they also tell you about head movement, head acceleration in 3 different planes, all right? And this is tremendously important. In fact, I would put to you that your vestibular system is the primary system because your vestibular system is the only system in your entire body that gives you a coordinate plane of where the world is, all right? So just think, if you're trying to figure out how you're gonna localize yourself in the environment, you have to be able to use eyes, inner ear, muscles, and joints, but you need a frame of reference. You need a frame of reference, right? And basically your X, Y, Z coordinates, right? Your vestibular system is the only thing that gives you that frame of reference, and everything else piles on top of that. Your visual pathways are glued on top of your vestibular system. The feedback from your muscles and joints is glued on top of your vestibular system. So if your vestibular system is giving you the wrong information, you have no clue where the world is. And as a consequence, you have no idea where you are. And your vestibular system basically starts with these systems here. So this thing over here, this is what you call an otolith, all right? And your otolithic system are basically, just think you have this big fluid-filled bag, and inside that bag, there's these hair cells that stick out from all these different directions, and hair cells are embedded in this gooey matrix, and on the end of the hair cells are these little rocks called otoconia, right? And then the idea is that if you have hair cells sticking out, little rocks cause them to bend down, all right? They create a perception of where gravity is. You will always have some hair cells that are bending down that allow you to make sense out of where up and down are. Now, imagine you have hair cells sticking up, right? Think of like the antenna on a car. Now, if you go and you jack up the rear wheels on the car, the antenna is going to bend forward, right? So those hair cells also tell you about tilt. If you slam that car in reverse, the hair cells are also going to bend forward. They tell you about translation, right? So you've got systems in your inner ear that give you feedback on all those different systems. Now over here, these things,